In the previous video, I proved the base case, and in this video, I will prove the inductive step. Now to review, we have a function f from the reals to the reals, and this property in the blue box is just given to us. This function just has this property. F of x plus y is equal to f of x plus f of y. And this is true for any two real numbers you put in here. And now we're going to use this property and induction to prove the property in the green box. All right, now let's review what we want to do. Remember, in a proof by induction, we're trying to prove P of k implies P of k plus 1. So let's write out P of k and P of k plus 1. P of k is f of kx equals k times f of x. And P of k plus 1 is f of k plus 1 x is equal to k plus 1 f of x. And remember, this is the assumption. Assume. This is what we're trying to show or prove. To prove. Okay, now to prove P of k plus 1, I'm going to start on the left-hand side with that thing, and then I'm going to work through a string of equalities using the property and the inductive assumption, P of k, to where I get to the right-hand side. Okay, so let's prove that now. So starting with the left-hand side, we have f of k plus 1 x. All right, now what I'm going to do is I'm going to use the distributive property inside of the f of. Okay, so what's going to happen is we have k plus 1 x, and as we know, that's kx plus x. Okay, so inside of the outer parentheses, we have this is f of kx plus x. Okay, now because of this right here, we know that k is a natural number. We're trying to prove this for all natural numbers. Now, because all natural numbers are real numbers, this property in blue works for kx and x. So what that allows us to do is use the property here, the property in blue, and so this is now f of kx plus f of x. So that's from the property in blue. Now we'll use the inductive assumption. Okay, notice that that right there is exactly that right there. All right, so now we use the inductive assumption, which tells us that f of kx is k times f of x. So this is equal to k times f of x plus f of x. All right, now we'll use the distributive property, and we'll factor out the f of x. So now we get to k plus 1 f of x. And you can see that we have started on the left-hand side here, this part here, and ended with the right-hand side right there. Okay, and so that is the proof of the inductive step.